start with our invited guest, Professor António Câmara. Professor Câmara has an outstanding curriculum, as you can see in our program. It's really hard to highlight something from that list, but maybe the Prémio Pessoa. Prémio Pessoa is one of the most important, or is the most important award in Portugal for a scientific contribution, and Professor Câmara was awarded Prémio Pessoa in 2006. And besides his scientific contributions, he also has enormous contribution to the ITC business in recent years, and has companies running all over the world. But Professor Câmara is really an entrepreneur, and for him, I think it's more important the future than the past, and it's the future and his vision about the future that we would like to ask him to share with us. So I will ask Professor Câmara to take the stage, and thank you for being here.
Well, first of all, thank you for inviting me to speak here. I'm going to talk about an experience both at university. I'm a professor at the University of Lisbon, but also in a group of companies called Wide Dreams. I've been the CEO and founder of the company in the last 14 years. Right now, my company is focused on being one of the major contributors to what can be called the Internet of Things, or the Internet of Everything, or any other name that is popping up. So my talk is about the building blocks for what I imagine to be the world, and to be the world as your browser. In a very simple manner, I look to the world as our browser. If we can augment and interact with objects and spaces. We can interact with objects in many ways. We can interact with objects as they stand. We can look to objects as an ecosystem where our objects that there is no sense of having any intelligence, to objects where we should add intelligence. And we can add intelligence in many, many ways. One of them is to select intelligent materials. Here is a picture of a bottle of water, and this bottle of water reduces its size whenever we drop the water on the glass. So we use smart polymers, and and the bottle decreases its size as the water is used. There are many, many other examples of intelligent materials using different technologies, from, for instance, electrochromics to thermochromics to piezoelectric materials and so forth. There are two problems with this approach. First of all, is that we are interacting with objects, but the result of that interaction is not communicated to anyone else. It's a standalone interaction. And the second is that most of the times, that interaction has a huge cost. For instance, if we have this smart bottle of water, this smart bottle of water will cost around 15 euros for the water that would cost 50 cents. I mean, it may make sense, for instance, in the perfume industry, but not for the water. We can also augment objects by including sensors. This is a picture of a suit that we did for firemen in the European Space Agency project some years ago. There were a number of sensors built in the garments. And right now, everyone talks about smart wearables. This is one way for the future, and certainly is not only being done, but for sure it will be done much more in the future. Then there are other views to augment objects. Instead of embedding sensors or intelligence, we can look to the world as augmented reality. I mean, one day we can imagine that we have glasses made of Google, Samsung, or any other maker, and I come to this room and I don't like the color of that wall. It's white. So basically I can turn it into green. So I can augment the space, but I can also augment objects. I can look to this bottle and then I can recognize all the properties of this bottle going to a website from Fashtil, which is the brand of this bottle. So that's another way to look on how to augment objects. And then, especially with the RFID initiative that started at MIT in 1990, that had the goal of decreasing the cost of RFID to 1 cent. There was this idea that instead of having barcodes, we will have RFID in any object at a very low cost that will be printed, and on that way we build intelligence on the object and also on the network. So there are many ways of augmenting objects, and most recently with basically the explosion in smartphones, there are many or more profound ways to increase the intelligence on everyday objects. Looking for instance, for a lamp, we can use the lamp to provide electricity to our smartphone, and by adding the smartphone to the lamp, we can have a smart lamp. We can have a lamp that moves, can be used for security, for video conferencing, and so forth. So you can augment objects not only by print electronics or augmented reality or using smart materials or sensors, but also having an add-on like a smartphone that will be the brain of that object. So there are a number of degrees of providing intelligence to objects. Well, I'm going to revisit two of the technologies I mentioned, augmented reality and print electronics. But before that, I really think that there is an overlooked area, which is geography. I'm biased because I worked in geographic information systems for many years, but I really think that when you look to the Internet of Things, one of the key things is to know where the objects are. And this is a challenge, especially indoors. So I really think that the building blocks for building the world as our browser are not only print electronics or augmented reality that can be used in separately or together, but first of all, microgeography. I really think that one day we'll know the exact position of almost anything. And I think that's a key building block for the Internet of Things. So what is microgeography? I mean, microgeography is about positioning objects, and that can be done in a number of areas, using triangulation, scene analysis, proximity. I have all the references and notes on this presentation. I'm not going to elaborate on those methods. Basically, the big challenges are indoors, because outdoors you have GPS, and indoors you can think about absolute positioning. The MIT Cricket project was a pioneer. Right now, the Apple beacons are just the same. These are radiometer devices that basically enable you to know where you are or the position of any object if it has the adequate sensors. And then you can have relative positioning through active badges. And in layman terms, we can imagine that I can know, if I have absolute positioning, I will know the latitude and longitude of this bottle right now. But most of the times, I really don't care about the absolute positioning of this bottle. I want to know only that this bottle is in this table, in this room, in this building, in this city. That would be enough. So you can have some sort of absolute positioning, which is the traditional geography, but you can have also relative positioning, which is some sort of the new geography. There are many companies working in positioning for indoors. My company has worked with several of them. The one that provides the most precise positioning is UBSense, which uses ultra-wideband. And I'm going to show a project where this technology has been used. So, as I said, we can look to microgeography in two ways. One is some sort of geometric in the traditional sense, and the other one is symbolic. And there was a PhD done at Imperial College several years ago where they used the set theory to create this new type of positioning. For most of us, we'll probably work on the symbolic approach, but underneath we will have the geometric if we want more precision. There are many questions in terms of the location models when you look to microgeography, because you are dealing with uncertainty on the geometric data, on the semantic data. You know what it means, a table on this room, for instance. We have several tables. On time, because if we build some sort of a hierarchy of the objects, that hierarchy can change over time. So there are several issues that can be researched on this area. And then what we'll be able to do if you have the positioning of every object. This basically is what location-based services are about, both outdoors and indoors. You can detect objects, you can do fencing, establish some sort of limits and detect where areas where special movements occur. I mean, for instance, I take the bottle out of this room, and if I have the right infrastructure, I will know that the bottle left the room. Navigations to go from an origin to a destination, and of course tracking. So there are lots of challenges, for instance, in terms of indoor mapping right now. Google now is mapping all the shopping malls, the active shopping malls in America. They will be part of Google Maps. So Google is building this infrastructure. And, and it's a new world. I mean, all of us work with architecture drawings of our house, but this will be something different. There are many approaches right now in shopping malls regarding the directories, but I really think that there are some challenges still in that area. And then how to build interfaces for a number of devices. There are two that are unusual. One is the solution by Zebra Imaging. Zebra Imaging is a company out of MIT that work in holograms, and they did the maps for Iraq on holograms because the soldiers couldn't use most of the times because of the luminosity computer screens. So basically they printed 3D holograms of the maps of different scenes in Iraq. And I imagine that would be very useful also for indoors. And then I'm going to talk about interfaces using printed electronics on a project we developed called Print2. We were in Kickstarter until a few weeks ago, and we were very successful. Actually, we worked in microgeography at the University of Lisbon in the 90s, and then in the early 21st century. And the first application we did was for Colombo Center. Colombo Center is one of the largest shopping malls. In Portugal, we always say in Europe, but I would say right now it's the second largest in Lisbon, but at the time it was the largest. So we looked on we wanted that everyone could go to Colombo and would find exactly the product that they wanted. Then we thought, well, this is going to be difficult. So we were happy that they would find the store where the product was. But really, the only useful result that came out of this exercise was the parking place finder. Every day there are about 1,000 people that got lost. They don't know where the car is because there are several floors and they don't know where the car is. So the parking finder was really absolute great result of this exercise. But anyway, we really think, we have worked on shopping malls all over the world in terms of directors. This will happen. One day we'll go to a place and we'll know exactly where the product will be. Some partners of ours in the Netherlands have worked a lot with hospitals. Same thing about, in this case, the location of the patients, the position of the healthcare personnel, routing exercises. I mean, many people here are from operations research, they know the algorithms. Actually, I have a slide on hospitals, but really the most successful cases were in prisons, but I thought it was too much for a 9 o'clock presentations. Right now, many jails in the US are privatized, and they hire these services so they have the great applications in microgeographies to detect the place of convicts. Okay, and then there are applications on security which are very interesting. And one of the challenges that we faced recently is the security in casinos. Because there are a number of people that are forbidden to enter. They have special cards, and supposedly they should be detected, but it's not as easy. So in this case, it's not so much a problem that can be solved using UV Sense, for instance, but a problem that can use a number of different approaches, including image processing. It's funny, for instance, someone is forbidden to go from a casino, and basically he has a disguise, uses cards from someone else, but then because of the patterns of him moving or the type of approach, a security guard can detect and can go there and expel him. So I really think that even if we worked about 14 years ago in this area, right now it's the time to build these microgeographical information infrastructures, and again, Google is going to be the first and the biggest mover. They understood the problem, and they are doing the work to have all the infrastructure in terms of location and positioning. And I really think that this is a big part of the future of the world is your browser. Imagine you're home, and I will design a microgeographical information system of your home. Then your glasses will never be lost. You know exactly where things are. We'll go in that direction. So from the shopping malls, we'll go to the offices and the homes. But anyway, so this is some sort of a building block, and it's a building block very similar to the one we used to explore the world. The first exploration of the world was geography, and now we are thinking of combining the world with the digital world, of creating a world as your browser. And again, I really think that microgeography is going to be a key, a new kind of geography. But really, there are two major approaches to build the intelligence on objects and spaces. And the first of course, is augmented reality. I really think that glasses are going to be one way, but I cannot see a large number of people wearing those glasses and looking to that angle all the time. You are looking that way. There are other approaches which are based on the smartphone, and Apple, for instance, is one of the companies with the largest number of patents in augmented reality. Or Android, and you look to the world with your smartphone all the time. I look to you and I know your name through the augmented reality search that I can do. So this is happening, but the extent of the influence of devices like glasses is uncertain, and I also question the continuous use of smartphones. They will be there somehow, but I will not bet everything on those devices. Anyway, you can have some sort of a roadmap of interfaces to the world by looking to the evolution of gaming. This is a very simple slide. It is a synthesis of both the interaction and representation of the world in the dimensions involved. And augmented reality is featured there. And but we really think that right now the world is much more complex than just a simple augmented reality exercise. What's happening right now is that in I think the big evolution, or the biggest evolution in devices in recent years was the incorporation of many sensors. iPhone was a dramatic change because it was the first device that could combine a large number of sensors, accelerometers, GPS, cameras, multi-touch, and so forth. And ARM, the chip maker, had built in the software to do the sensor fusion in a very right way, which enabled you to do very different interfaces. But what's happening right now is that you have a network of devices, each one with a number of sensors. And and ultimately, besides the sensors, you have also actuators. Right now, the actuators, for instance, in the phone are basically, the phone shakes or vibrates when we receive a call. I think there will be a big evolution in the forthcoming years on the actuator side. And if you have sensors, actuators, and processors, really you are starting to have robots that can be of different sizes, but you enter some sort of a robotic world. So we started developing a platform several years ago to handle this kind of this world, or this future world. And it's called Y-Vision. And basically we have a core that handles different modules, and those modules are basically, in most cases, open source software developed by third parties. So we have some sort of aggregator, and we have used it in a number of projects. And I'm going to start by the easiest one. Não consigo controlar aqui. Okay, so this is the easiest case. This is a Kinect camera. Well, actually, this is a Canesta camera. This was done in 2010. Canesta was then acquired by Microsoft, and they were our partner. And here, it's an example of natural user interfaces. You have a virtual world, and where the physics are correctly represented, and you can interact with those objects by gestures. And this is an illustration of one powerful sensor, which is the Kinect 3D camera. It's also an illustration of another view of the world. Actually, the most crawling application of this exercise is going to be this one. You enter in the screen, you pick an object, you rotate, and eventually you can buy it. So imagine you are watching a soap opera at home, and there's lots of products, and you want to buy a table there. And you point, you rotate the table, and you buy by impulse while you are watching TV. But anyway, so this is an example. Não é possível fazer a apresentação assim. O próximo vídeo vai ser igual, porque eu não posso ter isto de uma forma simples. É diferente só por causa da minha canal da conferência. Just a second.
Yes.
Yeah, it's very difficult because I have several videos and